You probably did not hate trigonometry because it was hard. You hated it because someone dropped 3 strange little words on you, sine, cosine, and tangent, before anyone told you what those words were actually measuring. So your brain did the sensible thing. It quietly filed the whole subject under scary and backed away. Then you memorized some ratios the night before a test and forgot every one of them by the weekend. Here is the part nobody said out loud. Trigonometry is not a wall of formulas. It is a simple tool built for one job. It finds the sides and angles of a triangle when you cannot just walk up and measure them with a ruler. How tall is that building? What angle is that ramp? How far away is that point across the river? That is the whole game. And once you see what the pieces are doing, the fear just falls off. I am Daniel, and this is Simplex Academy, where we take ideas that usually feel impossible and make them simple from the ground up. So let us rebuild trigonometry from zero, in the order it should have been taught the first time. Everything in trig starts with one shape, and it is not a fancy one. It is a right triangle. A right triangle is just a triangle where one of the corners is a perfect square corner, exactly 90 degrees. That is, the little square you always saw drawn in the corner. Why does trig care so much about this one shape? Because that square corner locks the triangle into behaving predictably. Once one angle is fixed at 90 degrees, the rest of the triangle follows reliable rules. And reliable rules are exactly what you need if you want to calculate something you cannot reach. Picture the friendliest example there is. A ladder leaning against a wall. The ladder is one side. The wall going straight up is another side. The ground stretching out to the base of the ladder is the third. Right there, without trying, you have made a right triangle. The corner where the wall meets the ground is your 90-degree angle. Keep that ladder in your head because we are going to solve real problems with it in a minute. Now let us name the 3 sides because these names are where most people get tangled. The longest side is always the one sitting directly across from the square corner. That side has a fixed name. It is called the hypotenuse. In our ladder picture, the ladder itself is the hypotenuse, the long slanted one. The other 2 sides are trickier because their names are not fixed. They change depending on which angle you decide to focus on. Pick one of the non-square angles, the one you care about for your problem. The side sitting directly across the triangle from it is called the opposite side because it is opposite to your angle. The side lying right next to it, forming part of the angle, is called the adjacent side because adjacent just means next to. So here is the whole thing in plain words. Opposite means across from. Adjacent means next to. And which side earns which name depends entirely on where you are standing in the triangle. That flexibility feels annoying at first, but it is actually the secret to how trig works. Let me show you the single idea that makes the entire subject click. Imagine you draw a small right triangle with a 30-degree angle in the corner. Now draw a giant one next to it, also with a 30-degree angle. One could fit in your palm, the other could cover a wall. They look totally different in size. But here is the quietly amazing part. If you compare the same 2 sides in each triangle, the height against the long slanted side, for example, and you work out that ratio, you get the exact same number in both triangles. Small triangle, big triangle, does not matter. Same angle, same ratio, every single time. That is not a coincidence. That is a deep rule about shape, and it is the reason trigonometry exists at all. Because those ratios are locked to the angle, we can give them names and reuse them forever. And that is all sine, cosine, and tangent really are. They are names for those fixed ratios. Nothing more mysterious than that. So let us meet the first one. Sine. Forget the formula for a second and just hear the question it answers. Sine asks, how tall is this triangle compared to its longest side? That is it. It compares the height, the opposite side, to the hypotenuse. So in ratio terms, sine is the opposite side divided by the hypotenuse. Watch it work on our ladder. Say the ladder is 5 meters long, and it leans so that the angle at the ground is 60 degrees. You want to know how high up the wall the top of the ladder reaches. You cannot climb up with a tape measure while balancing on it, but you do not need to. The ladder is the hypotenuse. The wall height is the opposite side. Sine of 60 degrees is about 0.9. So you take 5 meters, multiply by that ratio, and you get a wall height of about 4.3 meters. Sine just handed you a measurement you could not physically reach. Now the second one, cosine. Same triangle, brand new question. Cosine asks, How far along the ground does this triangle stretch compared to its longest side? It compares the base, the adjacent side, to the hypotenuse. So cosine is the adjacent side divided by the hypotenuse. Back to the exact same ladder. 5 meters, 60 degrees. This time you want to know how far the foot of the ladder sits from the wall. That base distance is the adjacent side. Cosine of 60 degrees is 0.5. 5 meters times 0.5 gives you 2.5 meters. So notice what just happened. Same ladder, same angle, but sine gave you the height, and cosine gave you the ground distance. Two different questions about one triangle, answered by two different ratios. Sine looks up the wall, cosine looks along the floor. And that leaves tangent, the third one, and it has a slightly different personality. Tangent does not care about the long slanted side at all. It asks the steepness question. How does the height compare to the ground distance? In other words, how steep is this angle? So tangent is the opposite side divided by the adjacent side. Here is where tangent really earns its keep. Imagine you are standing on the street, 10 meters back from a tall building, and you want its height. You cannot measure straight up the side of it, but you can measure the distance you are standing back, and you can measure the angle from your eyes up to the roof. Say that angle is 40 degrees. Your distance from the building is the adjacent side. The building height is the opposite side. Tangent of 40 degrees is about 0.84. 10 meters times that gives roughly 8.4 meters of building. You just measured a skyscraper with your feet on the ground. Let us take a breath because you now know the whole core of trig. 3 functions, 1 triangle, 3 questions. Sine, how tall? Cosine, how wide? Tangent, how steep? If that just clicked for you, that is exactly what this channel is built for, so consider subscribing to Simplex Academy. Hard topics explained from zero, without the fluff. Okay, let us make you dangerous with these, because here is the question everyone actually panics about. In a real problem, which function do I use? And the trick is to stop asking which formula you memorized. Ask a much simpler question instead. Which two sides are involved? Look at the side you already know and the side you are trying to find and just check the pair. If your two sides are the opposite and the hypotenuse, that is sine. If they are the adjacent and the hypotenuse, that is cosine. If they are the opposite and the adjacent, with the long side not involved at all, that is tangent. That is the entire decision. Two sides and the pair tells you the function. You may have heard the memory phrase, SOE ka toa. It is fine as a tiny reminder card for which sides go with which function. But please, do not let it be the whole subject in your head. It is a shortcut for something you now genuinely understand. The understanding comes first. The little phrase is just a sticky note on top of it. Now, everything so far has gone one direction. You feed in an angle, and you get a ratio, and then a side. But real life often hands you the reverse. You know the sides, and you need the angle. That is what the inverse functions are for. They simply run the machine backward. You give them a ratio, and they hand you back the angle that produces it. Say you are building a wheelchair ramp. It has to rise 1.5 meters over a run of 4 meters. You need to know the angle it makes with the ground, so it is not too steep. The rise is the opposite side, the run is the adjacent side, so the ratio you have is opposite over adjacent, which is a tangent situation. You divide 1.5 by 4 and get 0.375. Then you ask, what angle has a tangent of 0.375? On any calculator, you press the inverse tangent button, sometimes labeled with a small -1, and it tells you about 21 degrees. That is your ramp angle. You knew the sides, and inverse trig gave you back the angle. The process runs both ways, always. So where does all this show up outside a classroom? Honestly, everywhere you cannot reach with a ruler. Builders use it to cut roof beams at the right angle without trial and error. Surveyors find the height of a hill or a tower by standing a known distance away and measuring one angle. Your phone leans on these same ratios every time it turns your twists and turns into a straight-line distance to your destination. Video games use sine and cosine constantly to move a character smoothly on a diagonal. Anytime measuring something directly is hard, expensive, or impossible, trigonometry quietly solves it. Before we wrap up, let me save you from the traps that catch almost everyone, so they do not catch you. First, mixing up opposite and adjacent. Remember, those names are not glued to the triangle. They depend on which angle you chose, so always label from your angle first. Second, reaching for sine when the job needs tangent. Quick tell if the long slanted side is nowhere in your problem and you only have height and ground distance. That is tangent. Third, forgetting that these basic ratios only work on a right triangle. No square corner, and you need a different set of tools. Fourth, leaning on the letters without ever labeling the shape. The memory phrase is useless if you have not marked which side is which. And fifth, forgetting that inverse trig even exists, and getting stuck the moment a problem gives you sides and asks for an angle. So let us bring it home. Trigonometry was never a random pile of formulas. It is one clean idea. Because the ratio between two sides of a right triangle stays fixed for a given angle, we can name those ratios and use them to find things we cannot measure. Sine compares height to the longest side. Cosine compares the ground distance to the longest side. Tangent compares height to ground distance, which is just steepness. And the inverse functions run the whole thing backward, turning sides into angles. That is it. That is trig, the real version, the one that does not fall out of your head after the test. So tell me down in the comments, what part of trigonometry confused you the most back in school, and I might rebuild it from zero in a future video. And if this finally made trig feel less scary, subscribe to Simplex Academy. I am Daniel, thanks for watching, and I will see you in the next one.